Hello everyone, this is Juan Martinez. I work as a research and development manager for Bodegas Enguera. We are a third-generation family winery located in Valencia, in Spain. We're very much focused on organics, and in this project and this presentation I'm going to talk to you about the new threat to Mediterranean viticulture, which is the grape leafhopper. So first of all, let me introduce you to this pest. The grape leafhopper is formed by 4 insect species which are very difficult to identify them at sight. The main ones are Jacobiasca, lybica and Empoasca Vitis, as we will see later on, and they come from the family of Cicadelidae. Its life cycle is very important for us. It hibernates as adults and at the beginning of spring migrates to the vineyard, and from the beginning of July till the end of August is where we find the higher population levels of this pest. It causes serious damage to the plant, particularly when the population's levels are high. Basically the insect sucks all the phloem and parenchyma, all the internal tissues from the leaves, reducing its photosynthetic capacity. And as you can imagine, this fruit is not going to be as ripe as the fruit of a healthy vine. When the population of the leafhopper is very high, the vine can even lose its leaves before harvest time. So as you can imagine, we cannot make good quality wine from these grapes. So the objectives of this project was to learn more about this pest, basically to identify the leafhopper species we find in our weather conditions in Valencia, in Comunidad Valenciana, to understand more the life cycle of this pest. Evaluate the damage was another priority, and also it was very important to describe the implemented strategies that the farmer is currently developing. Also, as this is a publicly funded project, we wanted also to disseminate the results. Okay, let's see what we've done in this project. We were located in the east coast of Spain, in Comunidad Valenciana region. We visited the provinces of Castellón, Valencia and Alicante. And we monitor 10 vineyards in total in 9 locations. We wanted to identify very well the leafhopper species that we have in the vineyard. So we use a vacuum collector to capture the adults and then do the DNA barcoding. We used also yellow sticky traps to monitor the adults, as well as leaf sampling for monitoring the nymphs. Finally, we went to the vineyard just before harvest and we collect several hundred of leaves, did the image analysis to evaluate the damage of the grape leafhopper. Okay, so now let's see the results we found. Thanks to the DNA barcoding, now we know for sure that Jacobiasca lybica and Empoasca Vitis are the 2 main leafhopper species present in our vineyards, and in this the third one would be Asymmetrosca excedens, which is present not only in the vineyard but mainly in almond trees. We could also monitor cover crops and rosemary as well, where we find Empoasca decipiens. And as you can see on these graphs, in the vineyard where we find Jacobiasca lybica, we don't get Empoasca Vitis and vice versa, which for us is a very interesting result, also, although we have to consider that the sample of the sequences analyzed is not very high. This is a very interesting graph because it shows us that there are some vineyards like Enguera or Touriz that has a important level of damage. More than almost 80% of the leaf were attacked by the leafhoppers, whereas on the other side of the graph we have Requena, Useres and Venta del Moro with non-presence of this pest whatsoever. Basically, these locations are in the northern part of Comunidad Valenciana, whereas in the south is where we find a higher levels of grape leafhopper. Now let's look at the way farmers have fight against this pest. In this graph we can see a conventional farming strategy with systemic insecticides such as acetamiprid. They also use pyrethroids, synthetic pyrethroids. This strategy can be effective for controlling the pest, but the more insecticides we use, the more resistance the insect will get. So, as you can see in Novelda, they went almost weekly to treat the vineyard with insecticides, and they couldn't fully control the pest. So, in this case, we are sure that this pest is resistant to the insecticides they used. That's why we are more focusing on the way we can use organic farming to control this pest. A very interesting strategy is the use of kaolin treatments, because kaolin, as a clay, it creates a layer, a white layer in the vineyard that will make more difficult for the pest to lay its eggs, and therefore the pest would not develop in the crop. In the graph we can see that only 2 applications of kaolin can be very effective for reducing the damage of leafhoppers in sensitive varieties like Tempranillo, for instance, and in other varieties more resistant such as Marcellan. Also, this strategy is helpful for reducing the pest. Here you can see the vineyard after an application of kaolin, and I like very much this image because the dark part of the vineyard shows us a higher damage of leafhopper, whereas the white part and the green part, the levels, the percentage, the severity of the damage is lower. So the kaolin is a very interesting tool for controlling the pest in organic farming. The conclusion of this project is that although the sample size is moderate, Empoasca Vitis and Jacobiasca lybica are the most prevalent species present in all weather conditions. Leafhopper population developed exponentially at the end of June, reaching its peak in the middle of August. The grape leafhopper is present in 7 out of 10 vineyards, particularly in the southern part of the region, getting almost 70% of leaves affected by the pest in some vineyards like Enguera or Turis. And conventional insecticides can create resistance that reduce the effectiveness of the treatment. The use of kaolin, for instance of a dose of 3%, can reduce more than 30% of the damage of leafhoppers and does not create resistance nor negatively affect the beneficial insects. Finally, I want to thank all the partners of this project, as well as the wineries that offer us their vineyards to monitor this pest.